Okay, so today we're going to talk about properties of logarithms. So before we do that, I just want to review really quickly exponential form versus logarithmic form. So if I have something like y equals um, b to the x, it's the same thing as saying log base b, right? The base is always the same. Log base b of y is equal to x. The key, and I will repeat it a million times, is that, and I'm actually going to rewrite this because I think it's so valuable. X is equal to log base b of y. We are solving for an exponent. A logarithm is an exponent, and that is really crucial for today's lesson, is that a logarithm is an exponent. Because today we're going to use our exponent properties, what we already know about exponents, to work with logarithms. So let's just talk a little bit of foundations. And I wrote up here, everything in red is general form. So it's not given numbers, essentially. And everything in blue is going to be an example, which I'm going to be doing with my little pen here. So, foundations. And I'm going to talk about why for each of them, but I'm going to go a little quick. So if at any point you need to pause the video or rewind a little bit, you can. But I'm going to go a little quick so that this is not a 20-minute long video. Watch it end up being 20 minutes. So log base b of 1 is equal to 0. The reason, so this is just like a few foundations. The reason that this is true is because if you look at this, if I wrote this in exponential form, this is the same thing as saying, right? This is the same thing as saying b to the 0 is equal to 1. And that's true that anything to the 0 power is equal to 1 as long as b is not equal to 0. So an example of this would be log base anything, so 10, 50, whatever it is, of 1 is equal to 0. Anything. Okay, so now we have this one, which is log base b of b is equal to 1. The reason that this is true is because if I change this to exponential form, b to the first power is equal to b. That's just me writing it in exponential form. B to the first power is equal to b. True statement. So anything to the first power is itself. So an example of that would be log base 50 of 50 is equal to 1. Log base 97 of 97 is equal to 1. I'm going to keep one example here. Okay. Next. One-to-one property. Let's do one at a time. One-to-one property. So the one-to-one property is similar to our property of inequality, right? So this is the property of inequality for logarithms. We did a property of inequality for exponentials. So what we did was if we have b to the x equals b to the y, or for this we'll use m and n, right? B to the m is equal to b to the n, then that has to mean that m is equal to n. And when we did this back in the last unit, it was like 2 to the 5th is equal to 2 to the x, so x equals 5. So same concept with logarithms, okay? If log base b of n is equal to log base b, notice that it has the same base. So the base has to be the same. Then n has to equal m. So an example of this would be if I'm given log base 7 of 10 is equal to log base 7 of x plus 5, then I know that has to mean that 10 is equal to x plus 5, and then I can solve for x. Minus 5x is equal to 5. So that is the property of inequalities. Of equalities. I don't know why I said inequalities. Next, exponential logarithmic inverses. So this kind of has to do with this these two properties of equalities. So exponential logarithmic inverses. So this is the key, is that we're talking about inverses, the inverses of each other. And you'll notice for both of these, you have b to the log base of b, and then you have the log base of b of b. So that's where that inverse comes in. And we're going to talk about what that means. Now, I'm going to show you, for this one specifically, I'm going to show you an example before I show you the why. So if I have a value for my base, so let's say it's 5, and then I raise it to the log base 5 of 10. Okay, whatever, it doesn't really matter. I'm just picking random numbers here. It's saying here that this is going to be equal to 10. But for right now, let's just say is equal to what number? And let's figure out what that number is. So if I change this to exponential form, I'm going to get 5 to the, this is an exponential form. It's already 5 to the something equals something. So I'm going to change it to logarithmic form. So this is exponential form. And let's save that for later. Let's put this in logarithmic form. So it's going to be log base 5, right? And I'll even put it in blue. Log base 5 of, so it's going to be of x is equal to log base 5 log base 5 of 10. Right? So 5 to this power is equal to this. And also I'll even rewrite this, equal to x. So we don't know what it's equal to. But from our property of equality, if I have log base 5 of something and log base 5 of something, those somethings have to be equal. So this means that x equals 10. So what this means is that if I have log base 5, and I'll write it in blue because again, blue is the example. So if I have log base 5 and 5 is being raised to it, right? 5 to the log base 5 of anything, right? So here it was 10, it's going to be equal to 10. Another example is log 27 to the log base 27 of 602, right? Is equal, again, this is your exponent. This whole thing is your exponent. It's being raised to that power, is equal to 602. In a way, these are basically canceling each other out. It's kind of like the square root and squaring it, like the inverse operation, quote unquote. Okay, same concept here for this one, but it's like the opposite of it, right? So if I have log base b of b to a power, it equals m. So there's two ways to prove it. One is using the power property, but we haven't learned that yet. That's a little bit down further. But log base b of b to the m is equal to m. So let's do another example. So this is in logarithmic form, right? So if I have log base, let's do 5 again. Log base 5 of 5 to the 10th power equals something, I don't know, right? We do know what it is based on the example, but let's pretend we don't know. If we're putting this in exponential form, it is going to be my base to this power equals this whole thing. So it's going to be 5 to the x power is equal to 5 to the 10th power. And from our property of equality, we know that if they have the same base, then the exponents are equal. So therefore, x is equal to 10. So what we know here is that if I have log base 5 of 5 to the 10th, it's going to be equal to 10. Again, it's kind of like these cancel each other out. They're inverse operations. That's why it's called inverses. They are inverse operations. They kind of undo each other, so I just get 10. Another example, and I'll be like dramatic, log base 16.8 of 16.8 to the 42.9 is equal to 42.9. These undo each other.